I'd like to take a look at the exponential decay model. And generally the shape of this graph is going to look like this. It's decreasing, but the decrease levels off as time increases. And there are basically two ways to interpret this. One is to say that we have a base which is smaller than 1, or the other way is to use a negative exponent. So I'm going to demonstrate both of these models, and we're going to start with the base of less than 1. So if we take a look at this problem, assuming 15% depreciation, if a car originally cost $20,000, how much is it worth after 1 year, and then after 3, and after 10? So the original value of $20,000 we can think of as the starting value at time 0 in our graph. And now let's set ourselves up with an equation. And the one thing I'm going to use here is the 15% depreciation means that the value retains 85% year after year. So the basic equation I'm going to write, P of t, that is the value at any given time, is going to be that starting value of 20,000. And then I'm going to use that base of 85%, which is 0.85, and raise it to the power t. So if I calculate the value at 1 year, I get P of 1 is equal to the original value 20,000 times 0.85 raised to the first power. And that comes out to be $17,000. Next we can calculate the value at 3 years. So P of 3 is equal to 20,000 times 0.85 to the third power. And working that out on a calculator, we get this value for the exponent, and finally the value of 12,283. And finally, plugging in for P of 10, we can do a similar calculation, 20,000 times 0.85 raised to the 10th power. And with some rounding, we end up with $3,937. So we can see that the value decreases. Starting at 20,000, it goes down to 17,000 at the end of the first year, and then down to about 12,000 at the end of the third. And finally, a 10-year-old car is worth just a little under $4,000. Next, we're going to take a look at depreciation using an exponential model. And our original problem says 15% depreciation, but doesn't explicitly say exponentially. So the method that we used here would be correct. However, if we wanted to compare it to the exponential depreciation model, we would use this formula. P of t is equal to P0 e to the kt. And the information that we would insert from our problem is a starting value of $20,000. And the 15% depreciation we would represent as negative 0.15, and then times t. So we can complete our calculations for the various years. We have P of 1, which is the value after 1 year, is equal to 20,000 e to the minus 0.15 times 1. And when we work out those numbers, it comes out to be slightly higher than what we got from before. It's 17,214. And if we plug in for 3 years, we get that P of 3 is equal to about 12,753. And we can do a similar calculation at 10 years. And here we get that P of 10 is equal to about $4,462. And we can observe that there's a very slight discrepancy between the numbers for the two models. So for the first model, we've got at 1 year exactly 17,000, whereas for the exponential model at 1 year, we've got slightly more than 17,000. We've got 17,214. And the other numbers are similar, but again, slightly different. And the reason for this discrepancy is that they are essentially compounded at different frequencies. We can compare the first model to the interest formula of compounding annually. So you have some original amount or principal, and you multiply it times 1 plus r raised to the t power, and in this case, we're adding on a certain amount of interest at a certain rate, again compounded annually. And that, again, is similar to what we've got here, but in this case, the rate, because it's depreciation, is a negative value. The second model is similar to the formula that we would use for continuous compound interest, where the amount is equal to the original principal times e to the rt. And again, this time the interest rate, because it's depreciation, will be negative, where we're usually expecting it to be positive. So just as interest compounded continuously will differ slightly from interest compounded annually, we also have that depreciation, which is done on an annual basis, will differ slightly from depreciation, which is done continuously.